Nitrogen forms a number of oxo acids, such as hyponitrous acid, nitrous acid, pernitric acid, and nitric acid. Of these, nitric acid is an industrially important oxo acid. Let us first look at the various methods to prepare nitric acid. In the laboratory, nitric acid is prepared by heating potassium nitrate or sodium nitrate with concentrated sulfuric acid in a retort. The vapors obtained are condensed in a water-cooled receiver. On a commercial scale, it is prepared by Ostwald's process. The first step in this process is the catalytic oxidation of ammonia into nitric oxide. The nitric oxide is then oxidized to nitrogen dioxide, from which nitric acid is formed. Let us take a quick look at the process. First, a mixture of dry ammonia and air is passed through a catalytic chamber that is fed with preheated platinum gauze. The platinum gauze is preheated electrically to about 1155 Kelvin. It is a colorless liquid that boils at 84.1 degrees Celsius and freezes to a white solid at minus 41.55 degrees Celsius. Note that the specific gravity of laboratory-grade nitric acid, containing 68% by mass, is 1.504. In the laboratory, the nitric acid stored in bottles is usually yellow in color. Do you know why? Try to answer the question on your own before looking at the answer. Nitric acid undergoes photochemical dissociation to produce brown nitrogen dioxide gas. The brown nitrogen dioxide dissolves in the colorless nitric acid, turning it yellow. An aqueous solution of nitric acid undergoes ionization to produce hydronium ions and nitrate ions. On account of its ability to dissociate almost 100% to produce hydronium ions, it is considered a strong acid. On the other hand, the nitrate ions lend the acid solution its oxidizing property. Moreover, hot and concentrated nitric acid acts as a powerful oxidizing agent. You know that metals such as copper and zinc are insoluble in hydrochloric acid. However, these metals dissolve in nitric acid. The products formed depend on the concentration of the acid and the temperature. Concentrated nitric acid reacts with copper and zinc to give nitrogen dioxide. Dilute nitric acid reacts with copper to give nitric oxide and with zinc to give nitrous oxide. Certain metals such as chromium, aluminium, and iron are rendered passive towards an attack by nitric acid. This is due to the formation of a thin layer of oxide on the surface of these metals. Noble metals such as gold and platinum are insoluble even in hot and concentrated nitric acid. However, these metals dissolve in a concentrated solution of nitric acid and hydrochloric acid taken in the ratio of 1:3. This solution is called aqua regia. Note that noble metals dissolve in aqua regia due to its ability to produce nascent chlorine. The nascent chlorine eventually forms a soluble complex on reacting with gold and hydrochloric acid, as shown in these equations. Concentrated nitric acid oxidizes non-metals such as carbon, phosphorus, sulfur, and iodine to their corresponding higher oxo acids. The nascent oxygen produced from the dissociation of nitric acid oxidizes these non-metals. You can see from the balanced equations that carbon is oxidized to carbonic acid, phosphorus to phosphoric acid, sulfur to sulfuric acid, and iodine to iodic acid. Let us now look at the familiar brown ring test. This test confirms the presence of nitrate ions in a given salt. Freshly prepared dilute ferrous sulfate is added to the aqueous solution of a nitrate. The test tube is then slanted slightly and concentrated sulfuric acid is added drop by drop, allowing it to slide along the sides of the test tube. A brown ring forms at the junction of the two layers. The brown ring confirms the presence of nitrate ions. You can see from the equation that the ferrous ion reduces nitrates to nitric oxide. The nitric oxide formed reacts with ferrous ions to form a brown complex. The brown color is due to the formation of a hydrated nitrosyl complex of iron. Let us now turn to the uses of nitric acid. Nitric acid is widely used in the manufacture of dyes and drugs, as well as explosives such as trinitrotoluene or TNT, nitroglycerine, and picric acid. The salts of nitric acid, such as ammonium nitrate and calcium nitrate, are used as important fertilizers. It is used in the purification of silver and gold. It is used in the laboratory as an oxidizing and nitrating reagent. It finds a major use in the pickling of stainless steel, etching of metals, and as an oxidizer in rocket fuels.